Okay, so we are rationalizing denominators. Pretty much what that means is we are making them proper. Okay, so to make a fraction proper, you should not have a radical or an I in the denominator. Okay, so it says simplify each expression, assume all variables represent positive real numbers. So here we have a radical. You good? Don't die. You're fine. Just making sure you're good. Okay. Drink some water. We need to cancel that denominator's radical. Okay, the way we're going to do that is we need to double it. Multiply it by itself, right? Because then it's squared, and doesn't a square root cancel a squared? Yes, so we need to multiply it by root 7. Now, what I do to the bottom, I have to do to the top because that's what keeps it equal. Okay? So knowing that, I have 7 twice. Now, could I also multiply it and make it 49? Yeah, 7 squared is 49, so it wouldn't be changing anything. And then on top, I have 7. Well, remember, that's the same as saying 1 root 7. So 7 times 1 is 7 root 7. Well, the square root cancels the squared, and I'm left with 7 root 7 over 7. Does that simplify further?
Well, 7 with 7.
The 7's cancel. 7 divided by 7 is 1, and you end up with just root 7. Because that's inside of a house, not outside of a house. If you look to root 7, square root, not that one, square root of 7 is 2.645751311, so on and so forth. So it's not the same number. Do you see what I'm saying? That's why those can't cancel. So now if I had, never mind. Okay, so knowing that, on the bottom, it canceled. Okay, yeah. Oh, I had the calculator on it. Okay, so let's look at the next one. Same concept. So we're going to multiply it by itself because it's square root. Actually, freeze. Before I do that, let's simplify it. Why do you think I want to simplify it first? Yeah, I'm going to have smaller numbers, which are easier to work with. So I'm going to come over here. I have 27. What goes into 27? 3 9 times. What goes into 9? 3 times, right? Now this is a square root, so I'm looking for a pair of 2 3's. So I'm going to erase this. Not erase it, but cross it out. I have a 3 on the outside, and what do I have left on the inside?
3.
A 3. What else do I have left on the inside? X. And then I have a 9 on top. Now, what can simplify even further? 9 over 3. What's 9 divided by 3? 3. So this ends up being 3 over square root of 3x. Now, the numbers are a lot smaller, a lot easier to deal with. Okay, so now we're going to multiply by the denominator, which gives me 3x squared over, well, 3 times root 3x. Now, could I have multiplied it and gotten 9x squared? Yes. But what's the point of multiplying it if you're just going to cancel it? Okay. So, square root cancels the squared. And I get 3 root 3x over 3x. Can it simplify further? Yes, what crosses out? The 3's. And I'm left with root 3x over x. I have no more radical in the denominator, and I do not have an imaginary number in the denominator.
You can't cancel out the x's because one's in the house.
Because one's in the house and one's not. You're exactly right. Here on the bottom? Yes. So remember, the square root cancels the squared. That's why we multiplied by itself, was to make it squared so the square root would cancel it. What's different about number 3?
3.
3.
3 times 4 is 9. 3 times 4 is 24. 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 down one is a 3 square and not just an whole house?
Yeah, we have a cube root, not a square root. Okay? So in the last two, we doubled things to square them to cancel the square root. What do you think we have to do here? We want to triple it. We want 3, so the cube root will cancel the cube, right? Okay, so knowing that, not triple it, because triple it would be multiplied by 3, sorry, but multiply it by itself 3 times. So I already have one of them there. Nothing here simplifies, so we can just get started. How many more do I need to multiply to be able to cancel a cube? If I have 1 already there, I need 2 more, correct?
No.
So I can multiply it by cube root of 2 squared. Well, 2 times 2 squared, doesn't that just become 2 cubed? Because multiply it once and then 2 more times, so it's multiplying 2 3 times. Could you also just say 2 times 2 squared? Well, is 8. Okay, so if you'd rather write it like that, that's fine too. But what is the cube root of 8? What is the cube root of 8? Is 8 a perfect cube? Yeah, so what would it equal? 2. So all I'm doing here is just not simplifying it, so my cube root will cancel my cube. And I'll get 2. Well, if you write it like that, well, the cube root of 8 is 2. So if you'd rather write it one way or the other, that's totally fine. Now, on top, I want you to realize 2 squared is just 4, so 4 cube root 4. What simplifies?
4 and the 2.
What's 4 divided by 2?
1 and 2 and 1.
I do want y'all to realize that we multiply these together, which gives me 2 times 2 squared. That's why I was able to write it as 2 cubed, right? Because when they have the same house, you can multiply them together under the house. And that's 2 being multiplied 3 times, correct? That's why I wrote it as 2 cubed. Because there's 2 squared, which means 2 times 2. And then you have this 2 over here, which would be the 3rd time. Okay? Because right here we're multiplying to cancel the denominator.
Oh, so like 2 still has the power of 1 to it.
Yes.
So you add it with the 2 with the
Yes.
power of 2, which gets it to 2
Yes.
third. Okay, gotcha.
Okay, so let's look
On that as well.
at number 4. Okay, so on this one, I want you to realize that you can separate it. And you can write it as cube root 4 over cube root 3p. Okay? And knowing that, I need this to be 3p cubed. So I can cancel my cube root, right? So if this is 3p to the first power, how many more times do I need to do it? 2 more times. So I'm going to multiply now. What I do to the denominator, I have to do to the top as well. So if I have 3p to the first power here, 3p to the second power here, what does it become? Three p what? Cubed. And the top, well, the top, they're not going to cube anything, so we're not going to be able to cancel anything right away. So I want you to realize that this is 3 squared p squared, right? So what is 4 times 3 squared? It's 36. There's no p here, but this is p squared. So because we did this, we're able to cancel the cube root, and I'm left with 3p on the bottom. But I want to see if I can simplify the top. I don't know if there's a perfect cube inside 36. So you can come over here. 2 times what is 36? 18. 2 goes into 18 9 times. 3 goes into 9 3 times. Is there anything that happens 3 times? No, so I can't take anything out, therefore that is as simple as it gets. Tell me where you're lost. Okay, so all I did was split it up. So here, all I did was just rewrite it, but with the root split. Yes? Okay, I know this is a cube root. And you are not allowed to have any kind of root on the bottom. So how do you cancel a cube root? By having something cubed, right? So I have 3p one time. I have 1 3 and 1p. I need it 3 times, so I can cancel that cube root. Well, if this is 1 time, I need 2 more times to cancel it. So I did 3p squared times 3p to the first power, which gives me 3p to the third power. Huh? Because I already had 1. So if I multiplied it by 3p cubed, I'd have 3p to the fourth power, and cube root does not cancel a fourth power. So I'm trying to create something cubed so I can cancel my cube root. Does that make sense? Okay. It's the same thing as multiplying the denominator 3 times by itself. Okay? Because what you do on the bottom, you have to do on the top to keep it equal. So that's like here, we multiplied by this on top and bottom, multiplied by the same thing on top and bottom, multiplied by the same thing on top and bottom. Because that's what keeps it equal. What's anything divided by itself? 1, right? So anything times 1 is itself. So we didn't change anything mathematically. We're just rewriting it in a different way. Huh?
Does that mean the top on the problem doesn't mean anything?
No, it does. It's just properly you can't have a radical on the denominator. So that's all we're doing is we're putting them proper. I'm going to do a couple more. Okay, these are a little different. What do you notice is in the denominator? Yeah, there's subtraction. Okay, what we do, it tells you, it says you must multiply by the conjugate to make the radical go away from the denominator. Conjugate's a super fancy word for something that's not super fancy. Okay, the conjugate of 7 minus 2 root 3 is 7 plus 2 root 3. So what's the only thing that made it change?
It's
The subtraction changed to addition. That's how you created conjugate. And I'm going to show you why. So yesterday's practice, did we do one of the ones that cancels? No. Okay, look. Look at this bottom problem from yesterday's practice. These are conjugates, right? Because they're the same, but one's minus and one's plus. Yes? What happened to the middle two terms? They canceled out. And then the first and the last term doubled, so the radical canceled, yes? That's why we want to do this, because we cannot have a radical in the denominator, so we need to make them cancel. So that's why you do the conjugate. So watch. What I do to the denominator, I have to do to the numerator. And we're going to distribute. Now, I'm not going to distribute the top yet. And the reason being is, what if we get a number in the denominator that's a factor of 4? Will we be able to simplify? Simplify. I don't know why I had to think so hard to say that word. Okay, we won't be able to simplify. Or we'll have to take the 4 out again. Do you really want to put it in to take it back out?
No.
No, so let's just wait till the end before we multiply that in. Okay, now our denominator, we're going to double distribute. What's 7 times 7?
14.
Try again.
Jesus Christ. I added them.
49. Okay, and then 7 times positive 2 root 3. Well, 7 times 2 is 14, and that root 3 is still there. There was no root over here, so it didn't change. Everybody okay with what I've done so far? Okay, so then I'm going to do negative 2 root 3 times 7. Well, negative 2 times 7 is negative 14. Bring over that root 3. And then a negative 2 root 3 times positive 2 root 3. Well, a negative times a positive is a negative. 2 times 2 is 4. And what's 3 times 3? 9. What happens in the denominator in the middle? They cancel. I have positive 14 root 3 minus 14 root 3. That's a zero pair. They cancel. Okay. Now, what is so I'm left with 49 minus, well, what's the root of 9? Square root of 9? 3. So 4 times 3. What's negative 4 times 3? Negative 4 times 3. Negative 12. What's 49 minus 12? 37. So I end up getting 37 as my denominator, and I have 4, 7 plus 2 root 3. Does 4 over 37 simplify? It does not. So that is my answer. If you wanted to multiply that 4 in, that's totally fine. You could. Or you can leave it like this. So your answer would end up being 28 minus 8 root 3 over 37. So it's one of those. Those mean the same thing. Okay. So what's the conjugate of my denominator in number 6? Yeah, it's going to be the square root of x plus 2. So I'm going to multiply. I don't know why I tried to use that. Square root of x plus 2. What I do to the denominator, I also have to do to the numerator. So I like to handle the denominator first. What is the square root of x times the square root of x? Well, what's x times x? X squared. Okay, the square root of x times 2 is going to be positive 2 square root of x. So that's my first distribution. So my second distribution is negative 2 times the square root of x. And then negative 2 times positive 2, which is negative 4. What happens in the middle? They cancel. And what's the square root of x? Squared. Yeah, the square root cancels the squared. And so we get x minus 4 in the denominator. Now, my two factors in the numerator are square root of x plus 2, square root of x plus 2. That doesn't cancel with x minus 4, so nothing's going to cancel, so let's multiply the numerator. Square root of x times square root of x, square root of x squared. Square root of x times positive 2 is positive 2 square root of x. 2 times the square root of x is positive 2 square root of x. And 2 times 2 is positive 4. Square root cancels a squared, and I'm left with x. Now, these are like terms, so I'm going to combine them. What's 2 plus 2? Any questions on that one? Yes. Well, I zeroed these out. I circled those because they were like terms. So this is like canceling them because they're 0. Does that make sense? And then I circled those because they're like terms. 2 plus 2 is 4. So we combine them. Probably not my best idea, but you know. Jesse? Because it was positive 2 square root of x minus 2 square root of x. So there were 0 pairs. Yeah, sorry. Okay, so let's look at the last one. There's actually a couple different ways you can do this one. I'm going to do what I think is the easiest way. And the first thing we're going to try to do before we even try to make it proper is just try to combine the terms. What do we have to do to add or subtract fractions? They have to have a common denominator. So let's do our factor tree. Now, this one's not going to break down because 5's prime, so that's as simple as that one gets. But these two could probably break down because we have square roots. So 20 is 2, might help if you can see it, and 10, and then 2 and 5. Now this is square root, so I'm looking for a pair of 2 numbers. What do I have? 2. What was already outside though?
4.
So what's 4 times 2? And what was my leftover? 5. With 3 on top. Then I'm going to subtract 6 over something. So let's now break down 80. 2 goes into 80 40 times. 2 goes into 40 20 times. Remember, I'm just really cutting it in half. 2 goes into 20 10 times. 2 goes into 10 5 times. Do I have any pairs? Do I have 2 sets of 2?
Yes. Times it by
So 2 times 2 is 4. And what's my leftover?
5.
And then this third piece, the third term, doesn't break down.
Wait, so doesn't...
So the cool thing is they all already have root 5.
So that means they can all come together?
Not yet, because the denominators have to be exactly the same to add or subtract fractions. So I have this 8 in front, I have a 4 in front, and technically I have a 1 in front. What can 8, 4, and 1 all turn into? 8. This already is 8.
Yeah.
How would I turn this into 8 square root of 5? Multiply by 2. What I do to the top, I have, or the bottom, I have to do the top. And what would I do here to turn this into 8 square root of 5? Multiply by 8. These are all going to equal 8 square root of 5 now, correct? So I'm just going to do one line and put 8 square root of 5 in the denominator. And I have 3 minus, what's 6 times 2?
12.
Plus, what's 2 times 8?
16.
So I'm going to figure that out. 3 minus 12 plus 6, not 40. 16 is 7. So I end up with 7 over 8 square root of 5.
Sweet.
Now, am I done?
Probably not.
Probably not. What am I not allowed to have in the denominator? The radical. So how do I get rid of a radical 5? By multiply by radical 5. Now, the 8 is fine, right? So do I need to mess with the 8?
No.
No, 8's fine. So we're going to multiply just by the radical of 5. So that leaves me with 7 root 5 in the numerator. And what does that give me in the bottom?
8 times 5.
So you can say 8 times 5 squared, or root of 5 squared, or you can say 8 square root of 25. Well, 5 squared is 25, but what is the square root of 25, or the square root of 5 squared? 5. So we end up with 7 root 5 over 8 times 5. What's 8 times 5?
40.
7 over 40 does not simplify, so that's your answer. Okay, now you could have canceled your root 5's way over here, but then you would have done it 3 times. You see what I'm saying? I waited till the end to make it proper, just so I'm not doing everything a billion times. Okay? Okay, there's actually one on your practice I'm going to do with you as well. Look at number 4.
I'll see you probably next week. If I
Sounds
go to
good.
school.
Yes, ma'am. Okay. So I have a square root. I have things inside. I'm going to go ahead and separate it. Now, there's kind of 2 ways you can do this. If you want, you can simplify the denominator now. Or can you just multiply it by itself and simplify at the end? So you can do either way. So let's just multiply by itself. So if I multiply the denominator by r cubed, square root of r cubed, because I'm trying to make this happen twice so I can cancel the square root, right? I end up getting g cubed h4r cubed, because remember they have the same root so they can go in the house together, over, well, what's 3 plus 3?
6.
Can I cancel a square root with a 6? Yes, because I want to write it as something squared, right? What's 6 divided by 2? 3. So the square root cancels the squared, and what's left in my denominator? R cubed. So I have r cubed in my denominator. But now my numerator, I want something squared, something squared, something squared for each of those letters as well. Now, might I have leftovers? Yes, I might have remainders. So how many times does 2 go into 3? 1. So this gives me g squared, which means I have 1 g left, right? To make 3 g's. Okay, now h to the 4th, how many times does 2 go into 4? Oh, h, not r. So 2 times 2 is 4. I don't have any remainders. That was fine. And then I have r cubed, well, 2 here, and then I'm going to have 1 remainder. So I know that this is not going to come out of the house because it doesn't have anything squared. This cancels that, and that, and I'm left with g h squared r. Can the r's simplify? Where do I have more r's, top or bottom? What's 3 minus 1? So I have more on bottom, so they stay on bottom. I'm left with g h squared gr. I did that one with y'all for a reason. Now there's 2 more like hints I want to give you. Okay, and then I'll let y'all practice. Number 3, the denominator is already squared and it's a square root. Do you have to multiply by anything? No, just separate your root and simplify. Okay, don't make it harder than you have to. Okay, also look at number 7, or even number 5. They both kind of have the same concept. These are both cube roots, correct? Well, this already has an x squared. What would you need to multiply an x squared by to become an x cubed? By just 1x, right? So are you going to multiply it by x squared or just x? Same concept here. Can you rewrite this as 2 squared? So you only need to multiply the denominator by the root of 2, cube root of 2, to make 2 cubed. Okay?